All right, ladies and gentlemen, so today we're going to do our powers of 10. We're going to use our powers of 10 and our magnitude to help us solve some problems here. So we're just going to start off right away with a question. So in 1723, the population of New York City was about 7,248. By 1870, almost 150 years later, the population had grown to 942,292. Determine approximately how many times greater the population was in 1870 compared to 1723. So first of all, we're going to have to divide. So if I want to know how many times greater, that's really telling you to divide. All right, well, approximately means that we can estimate. All right, we don't have to have an exact answer. So what we're going to do is we're going to do what we did with our magnitude, and we're going to come up with and try to help us solve this problem. So I'm going to write the population of 1723 using a power of 10. And remember, we count the number of places, 1, 2, 3, 4, and then we add 1. So that's about 10 to the 5th power. For 1870, we have 1, 2, 3, 4, 5, 6. So we add 1, that's 10 to the 7th. So now we're going to divide. So we're dividing 10 to the 7th divided by 10 to the 5th. So this is from the first part of the chapter. My bases are the same, so we keep the base, subtract your exponents, 10 squared, which, if I did that, would be 100. So the population in 1870 was 100 times bigger than it was in 1723. All right, now we're going to try to be a little bit more precise with our estimation. Let's do the problem again, but instead of just using powers of 10, let's use a single digit times a power of 10. All right, so we have to go back and look at those populations. So 7,248 is really 7 times 10 to the 3rd power. And the population in 1870 is really 9 times 10 to the 5th power. I hope I counted correctly. Yes, okay. So now, same idea. So we're still going to do our dividing. 9 times 10 to the 5th over 7 times 10 to the 3rd. Well, compare the populations, use what we know about the laws of exponents. So what I have to do here is I have to now take and I have to divide those. And that's going to divide out 9 divided by 7. It's going to give me a repeating decimal, but that's okay. So we'll excuse me. We're going to rewrite it. Clear. So 9 divided by 7 is going to give me about 1.3. I'm going to round that, right? You divide your coefficients. Keep your base, subtract your exponents. So now if I were to multiply this out, that's 1.3 times 100, which is really 130 times as big. So which answer is more precise? The second one. All right, so let's see what else we can do here. So we're just kind of putting a bunch of different things together. So compare the population of New York City to the population of New York State. Find out how many times greater the population is compared to that of New York City. So again, we're going to try and use the single digit method. So I can rewrite this 8,336,697 as 8 times 10, and I'm going to count how many numbers were after that. 1, 2, 3, 4, 5, 6. New York State is about 19. I'm going to actually round that up to 20 because it's approximately. So 20 million, so that's 2 times 10 to the 1, 2, 3, 4, 5, 6, 7 power. So now I'm going to take and I'm going to divide those. So 2 times 10 to the 7th over 8 times 10 to the 6th. 2 divided by 8 is 0.25 times, keep your base, subtract your exponents. All right, so now this really just means 0.25 times 10, which is 2.5. So the population of New York State is about 2.5 times as big as the population of New York City. There are about 9 billion devices connected to the internet. That is a lot. If a wireless router can support 300 devices, how many routers are necessary to connect all 9 billion devices wirelessly? Well, 9 billion looks like this. Right, that's 9 billion. That was a lot of writing. 300 is obviously pretty basic there. But I'm going to rewrite this. So instead of 9 with all those zeros, I'm going to do it as a power of 10. So 9 times, and we're going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to do the same thing for the 300. 300 times 10 to the second. 1, 2. These I can divide easily. 9 divided by 3 is 3. So you're dividing your coefficients. Keep your base. 10. Subtract your exponents. 7. So we need 3 times 10 to the 7th. Another way to write that, right, with our 7 zeros. So that would be 30 million routers is how many are needed. The average American household spends about $40,000 each year. If there are about 1 times 10 to the 8 households, what is the total amount of money spent? So this time we're going to actually be multiplying. So I'm going to take my 40,000, I'm going to write it as a power of 10. So 4 times 10 to the 1, 2, 3, 4. And then we're going to multiply that by 1 times 10 to the 8th. Right, so just like before, we're going to take and multiply our coefficients. 4 times 1 is 4. We're going to keep our bases, and we're going to add our exponents. 10 to the 12th. Which, if you want to write that out, looks like this, 4 with 12 zeros. All right, so that's a lot of money. The average person takes about 30,000 breaths per day. If the average American lives about 80 years, or about 30,000 days, how many total breaths will they take? So, same idea. So we're going to write it as a power of 10. 3 times 10 to the 1, 2, 3, 4. Times 3 times 10 to the 4th. We multiply our coefficients, 9. Keep your base. 4 plus 4 is 8. 9 times 10 to the 8 breaths. All right, so it's kind of putting a bunch of different stuff together that we've been working on, but nothing too challenging, hopefully. But if you have questions, you know to bring them to class. Have a good day.